The distinction between communication cable and CATV cable hinges on the cable's intended purpose. Communication cable serves to transmit voice, data, or video signals within premises wiring systems. These systems include telephone networks, intercom systems, and security setups. CATV cable, conversely, is specifically engineered for transmitting analog or digital television signals within cable television systems. Examining the application of Articles 810 and 820 to distributed antenna systems, or DAS, Article 810 does not apply, as it specifically addresses CATV coaxial cables within cable television systems. Article 820 may apply to the segment of the DAS utilizing coaxial cable for analog radio frequency signals contingent upon meeting certain conditions. Firstly, the coaxial cable must be installed in accordance with Article 820. Secondly, the DAS should be regarded as a CATV system as defined in Article 800.2, owing to its use of analog radio frequency signals. Regarding the classification of DAS cables, coaxial cables within an indoor DAS can be categorized into two types. Firstly, communication cable, which is employed for transmitting voice, data, or video signals excluding analog radio frequency signals, examples being Ethernet, IP video, and voice over IP. These cables necessitate a CM rating and testing under UL-910. Secondly, CATV cable is dedicated to transmitting analog radio frequency signals. These cables must possess a CM rating and undergo testing under both UL-910 and UL-444. In conclusion, the majority of indoor cables in a DAS should be classified as communication cables complying with Article 800 requirements, as they predominantly carry voice, data, or video signals, distinct from analog radio frequency signals. Nonetheless, in instances where analog radio frequency signals are integral to a segment of the DAS, the pertinent sections of Article 820 might govern the coaxial cables responsible for conveying these signals. It's crucial to understand the specific characteristics and applications of these cables to ensure compliance and optimal performance within a DAS environment. The distinction is pivotal for guaranteeing adherence to safety standards and regulatory requirements. Furthermore, proper classification and implementation directly influence the reliability and efficacy of the DAS network. Considering the increasing integration of distributed antenna systems within diverse environments, a thorough understanding of cable classifications becomes indispensable for industry professionals. This understanding facilitates informed decision-making during design, installation, and maintenance phases. The selection of appropriate cables, guided by accurate classification, ensures seamless operation and mitigates potential risks associated with signal transmission. Understanding these distinctions is crucial for ensuring the safety, compliance, and performance of DAS installations. Communication cables, designed for voice, data, and non-RF video, adhere to Article 800 and undergo UL-910 testing. CATV cables, specifically for analog RF signals, may fall under Article 820 and require both UL-910 and UL-444 testing. This precise categorization is vital for proper installation and maintenance. Let's explore each of these concepts in further detail. Firstly, communication cables are essential components in modern infrastructure, facilitating the seamless transmission of voice, data, and video signals. These cables serve as the backbone for various applications, including telephone systems, intercoms, security networks, Ethernet connections, IP video streaming, and voice over IP communications. The versatility and reliability of communication cables make them indispensable in both residential and commercial settings. Designed to meet stringent performance standards, communication cables ensure clear and uninterrupted signal transmission across diverse environments. They are engineered to minimize signal loss and interference, thereby maintaining the integrity of the transmitted information. Whether it's connecting computers in an office network or enabling video conferencing in a corporate boardroom, communication cables provide the necessary infrastructure for seamless connectivity. Moreover, these cables play a vital role in supporting emerging technologies such as smart home systems, IoT devices, and cloud-based applications. Their ability to handle high-bandwidth signals ensures that data-intensive tasks are executed smoothly and efficiently. In addition to their technical capabilities, communication cables are also designed with safety in mind. They are constructed from fire-resistant materials and undergo rigorous testing to ensure compliance with industry standards. This commitment to safety minimizes the risk of fire hazards and protects both property and personnel. Furthermore, communication cables are available in a variety of configurations, allowing for customized solutions tailored to specific installation requirements. Whether it's shielded cables for high-noise environments or plenum-rated cables for air-handling spaces, there is a communication cable to suit every application. Secondly, CATV cables are specifically designed for transmitting analog or digital television signals within cable television systems. These cables are engineered to deliver high-quality video and audio content to subscribers' homes, ensuring a seamless entertainment experience. CATV cables play a crucial role in the distribution of television programming, providing a reliable connection between the cable provider's headend and the customer's set-top box. They are designed to handle the complex modulation schemes used in cable television transmission, ensuring that signals are delivered with minimal distortion or interference. In addition to television signals, CATV cables can also carry internet and telephone services, providing subscribers with a comprehensive suite of communication solutions. Their ability to support multiple services makes them an essential component of modern broadband networks. CATV cables are constructed from high-quality materials that are designed to withstand the rigors of outdoor installation. They are resistant to moisture, UV radiation, and temperature extremes, ensuring reliable performance in diverse environmental conditions. Furthermore, CATV cables are available in a variety of shielding configurations to minimize signal leakage and interference from external sources. The shielding is essential for maintaining signal integrity and preventing unauthorized access to the cable television network. In addition to their technical capabilities, CATV cables are also designed with safety in mind. They are constructed from fire-resistant materials and undergo rigorous testing to ensure compliance with industry standards. This commitment to safety minimizes the risk of fire hazards and protects both property and personnel. Thirdly, the application of Articles 810 and 820 to distributed antenna systems, or DAS, requires careful consideration to ensure compliance with electrical codes and safety standards. Article 810 of the National Electrical Code, or NEC, specifically addresses radio and television equipment, while Article 820 pertains to community antenna television, or CATV, and radio distribution systems. Understanding the scope and requirements of these articles is essential for designing and installing DAS systems that meet regulatory guidelines and minimize potential hazards. Article 810 provides detailed instructions for grounding and bonding radio and television equipment, including antennas, lead-in conductors, and surge protective devices. It specifies the size and type of grounding conductors required to safely dissipate electrical surges and prevent damage to equipment. Additionally, Article 810 outlines the proper methods for installing antennas and lead-in conductors to minimize the risk of electrical shock and fire. Article 820 focuses on the installation and grounding of CATV and radio distribution systems, including coaxial cables, amplifiers, and splitters. It specifies the requirements for bonding and grounding these systems to minimize the risk of electrical hazards and prevent interference with other electronic equipment. Additionally, Article 820 outlines the proper methods for installing coaxial cables to ensure signal integrity and prevent signal leakage. When applying Articles 810 and 820 to DAS systems, it is important to consider the specific characteristics of the system and the equipment being used. DAS systems often incorporate a combination of radio and television equipment, as well as CATV components, requiring a comprehensive understanding of both articles. In some cases, it may be necessary to consult with a qualified electrical engineer to ensure compliance with all applicable codes and standards. In many DAS installations, Article 810 might not be applicable because it specifically deals with CATV coaxial cables within cable television systems. However, Article 820 could apply to the section of the DAS that uses coaxial cable for analog radio frequency signals if certain requirements are fulfilled. Firstly, the coaxial cable must be set up according to Article 820. Secondly, the DAS must be treated as a CATV system as specified in Article 800.2 due to its utilization of analog radio frequency signals. The classification of DAS cables is also an important factor to consider. Coaxial cables in an indoor DAS can be classified as either communication cables or CATV cables, depending on their intended use. Communication cables are used for transmitting voice, data, or video signals that are not analog radio frequency signals such as Ethernet, IP video, and voice over IP. These cables should be CM rated and tested under UL-910. CATV cables, on the other hand, are used for transmitting analog radio frequency signals and should be CM rated and tested under both UL-910 and UL-444. Understanding the differences between these types of cables is essential for ensuring proper installation and compliance with electrical codes. Fourthly, UL-910, also known as the Steiner tunnel test, is a fire test standard for determining the flame spread and smoke density characteristics of building materials and electrical cables. This test is commonly used to evaluate the performance of cables installed in plenum spaces, which are air handling spaces above suspended ceilings or below raised floors. UL-910 is widely recognized as a critical benchmark for assessing the fire safety of cables used in commercial and residential buildings. The test involves subjecting a sample of the cable to a controlled fire in a horizontal tunnel while measuring the distance the flame spreads along the cable and the density of the smoke produced. Cables that pass the UL-910 test are designated as plenum rated, indicating that they are suitable for installation in plenum spaces where fire safety is of utmost importance. Plenum rated cables are designed to resist flame propagation and minimize smoke production, thereby reducing the risk of fire spread and improving visibility for occupants during a fire emergency. In addition to plenum rated cables, UL-910 also applies to other types of building materials, such as wall coverings, ceiling tiles, and insulation. These materials are tested to determine their flame spread and smoke density characteristics, ensuring that they meet the fire safety requirements for their intended application. UL-910 is an essential tool for architects, engineers, and building contractors who are responsible for specifying and installing fire-resistant materials in buildings. By selecting materials that meet the UL-910 standard, they can help to improve the fire safety of buildings and protect occupants from the dangers of fire and smoke. The UL-910 standard has had a significant impact on the design and construction of modern buildings, leading to the development of safer and more fire-resistant materials. As a result, UL-910 has become a widely recognized and respected standard for fire safety in the building industry. Fifthly, UL-444 is a safety standard that covers thermoplastic insulated wires and cables for use in accordance with the National Electrical Code, or NEC. These wires and cables are intended for general-purpose wiring in buildings and other structures, and they must meet specific performance requirements to ensure their safety and reliability. UL-444 specifies the construction, materials, and testing requirements for thermoplastic insulated wires and cables, including conductors, insulation, jackets, and markings. The standard covers a wide range of wire and cable types, including single conductor, multi-conductor, and coaxial cables. It also specifies the allowable temperature ratings, voltage ratings, and ampacity ratings for these wires and cables. To comply with UL-444, thermoplastic insulated wires and cables must undergo rigorous testing to ensure that they meet the performance requirements specified in the standard. These tests include electrical tests, mechanical tests, and flammability tests. Electrical tests are conducted to verify the insulation resistance, voltage withstand, and conductor resistance of the wires and cables. Mechanical tests are performed to assess the tensile strength, elongation, and abrasion resistance of the materials used in the wires and cables. Flammability tests are conducted to determine the flame retardant properties of the insulation and jackets. Wires and cables that meet the requirements of UL-444 are marked with the UL listing mark, which indicates that they have been tested and certified by underwriters' laboratories, or all. The UL listing mark provides assurance to consumers and installers that the wires and cables have been evaluated for safety and performance and that they comply with applicable standards. UL-444 plays a critical role in ensuring the safety and reliability of electrical wiring systems in buildings and other structures. By specifying the construction, materials, and testing requirements for thermoplastic insulated wires and cables, UL-444 helps to prevent electrical hazards and protect people and property from the risks of fire and electrical shock. In summary, understanding the nuances between communication and CATV cables, the relevant articles in the National Electrical Code, or NEC, and the significance of UL standards like UL-910 and UL-444 is critical for ensuring safety, compliance, and optimal performance in distributed antenna systems, or DAS, installations. This knowledge empowers industry professionals to make informed decisions regarding cable selection, installation practices, and maintenance procedures, ultimately contributing to the reliability and effectiveness of DAS networks in diverse environments.